Hi, this is the third video in the series where we're looking at the June 2018 Edexcel higher paper. In the previous video we've stopped at question number 12 and we're going to be starting here from question number 13. Please do stop the video, have a go at each of the questions and then compare your solutions. Okay, so we're going to aim to make this video around about 25 to 30 minutes long, and hopefully this will give you about an hour's worth of fairly focused revision. We are starting from question 13, which is a little bit tricky, but hopefully it should be okay for you. So please do have a go at this question and then compare your solution. What we're being asked to do is to show that y minus x equals 90 degrees, and you must give a reason for each stage of your working. Okay, I don't think this is a particularly easy question to kind of work through. These sort of proofs, I think, are quite tricky. If you do get the opportunity, please do practice this as much as possible because they do come up in exams. Okay, so let's have a look at firstly the diagram, and what I'm going to say is that actually I can work out that this angle here is x. Now the reason I know that's x is because triangle BOD is an isosceles. Okay, and because it's an isosceles, and the reason it's an isosceles is because we've got two radius here. Okay, so it must be an isosceles, and what that means for me is that angle OBD is also equal to x degrees. So if you like, that's my first kind of reason that I'm going to put into here. Okay. The second thing I'm going to look at is actually this angle at the top here. Now, this angle at the top is going to be 180 minus y. Okay, 180 minus y. Now, the reason I know that is because this BCDA is a cyclic quadrilateral. Okay, so because it's a cyclic quadrilateral, it means that the opposite angles add up to 180 degrees. So I can see that angle BCD is equal to 180 degrees minus y. Okay, and the reason I'm going to put in here, and you might want to elaborate on this, but it's because it's the opposite y degrees in a cyclic quadrilateral. Okay, alrighty. So we've got two kind of reasons, if you like, going on within this particular one. So let's have a look then at the final bit, is that we've actually now got this triangle in the middle here. Okay, but what I also know, because I know the the outside angle at the circumference is that, then I know that this is going to be double the value because the angle at the center is double the angle at the circumference. So what I can say now is that angle BOD is equal to 360 minus 2y, and the reason that is because it's double 180 minus y. Okay, and again you might want to fill in a little bit more detail on this, but it does put us in quite a strong position now because we now have effectively a triangle. So in that triangle we've got, and this is the little triangle. If I just sort of go back to this, what I'm going to do is this triangle here. Okay, so if I now fill in the angles, I've got this one that is this bit, and I know this is x, and also the other side is x as well. Okay, right, so now we're in a position where we can actually use this information to prove that y minus x equals 90 degrees. Okay, so what we're saying is that all of these three angles add up to 180 degrees, so we can write what x plus 360 minus 2y equals 180 degrees, and that's true, isn't it? Because that's the value of all the angles in a triangle. Okay, and basically now it's a case of just tidying this up. So if I tidy this up, I've got 2x and that's minus 2y. I'm going to put those two terms together, or those two together, and then that one with it, and that's going to be plus 360 equals 180. If I take 180 away from both sides, I end up with 2x minus 2y plus 180 equals 0. Okay, so then if I divide through by 2, I'm going to get x minus y plus 90 equals 0. Now that's actually the proof itself, but they want us to show it in that form. So what I'm going to do is I'm going to leave the 90 in place, but if I move the x and the y over to the other side, I get a negative value of x and a positive value of y, because if I add y to both sides, this becomes positive y. If I minus x from both sides, this becomes minus x. Okay, so I can write that as 90 equals y minus x. And actually, that's the solution to this question. Is a little bit tricky, and it does take a little bit of time to work through, but I do suggest if you get the opportunity, please do have a look at some other questions and see if you can at least score a few marks on these types of questions. Okay, then it says Dylan was asked to give some possible values for x and y. He put y could be 200 and x could be 110. Okay, well actually y couldn't be 200 because it's a triangle. Okay, so I would just simply with this, I'd say that y must be less than 180 degrees as it's a triangle. Okay, so what we could say, and again, you know, it's up to you how far you go with these sorts of things, is that, you know, you could say, well actually I've got a triangle, it would be almost impossible for me to draw on the screen here, but this would be 179 degrees and this would be 0.5 degrees and 0.5 degrees, if that's really what you wanted. Okay, hope that's all right. Let's move on to question number 14. Okay, so question number 14, we've got a distance time graph, and it shows the information of a car journey. Use the graph to estimate the speed of the car at a time of 5 seconds. Well, speed is distance over time, or change in distance divided by change in time. So really, the only way of doing that is by drawing this as a tangent. And hopefully, again, you'll be able to see on the screen that I can draw. It's not going to be particularly accurate, but hopefully it'll give you some idea of what we need to do here. So we can draw a tangent like that to this point of 5. Okay, now inevitably these sorts of things are not going to be particularly accurate, but it will give you some idea of what they're looking for in this type of question, because what we can say then is that speed equals distance travelled divided by time taken. Okay, so the distance travelled is going to be the difference between 0 and what I got there, something like 75. I think I did it on my about 75 on my notes here, so I got 75, and it took a time of 8 take away 3, which is going to be 5. So he travelled a speed of 15 meters per second. Okay, that's actually it. That's the answer to this particular question. So that's 3 marks, relatively straightforward, providing you remember to draw the tangent. Okay, so let's move on then to question number 15. Question number 15, we've got a nice probability tree here. Okay, and like a lot of similar sort of questions, they ask us firstly to fill out and complete the probability tree diagram. We don't really need to read text for that, but you can see hopefully from the probability tree diagram that if the probability of winning is 0.45, the probability of not winning or losing is 0.55. Okay, and then it says if they win on a Saturday, so if they win on a Saturday, the probability they will win on a Sunday is going to be 0.67. So I can put that in, 0.67, and then that would mean that not winning or losing would be 0.33. Okay, and then it says if they do not win on a Saturday, the probability that they will win on the Sunday is 0.35. So I can go through the same exercise, 0.35, and that means losing would be 0.65. Okay, so that will give us 2 marks to fill in that particular probability tree. Let's look now at the outcomes themselves. And I generally tend to do this because it just gives me a little bit of a bird's eye view as to what's going on. That if I follow this branch, I've got win-win. This is the outcomes. Okay, so they're a particularly good Saturday and Sunday, win-win. Okay, and then they've got a win and a lose and a win, and then a lose and a lose. Okay, and then it says in part B is find the probability that the team will win exactly one of the 2 matches. Okay, so exactly one. So the probabilities that we're interested in is that one and that one, because in both of those scenarios they've won exactly one of the matches. Okay, so we'll look at the first one is win-lose. So the probability of win-lose is going to be 0.45 for a win and 0.33 for a lose. So we've got 0.45 times 0.33. You pop that in your calculator, you're going to get something like 0.1485. Okay, so that's win-lose. Lose-win. Go the other way. Okay, so 0.55 and then 0.35. Okay, so again, pop that in your calculator, 0.55 times 0.35, and that's going to give you 0.1925. Okay, so the probability that they will win exactly one of the managers is these 2 probabilities added together. So that's going to be that one plus that one, and the probability overall is going to be 0.341. And actually that's the answer to the question. If you prefer, you can write it as a fraction, so that'd be 341 out of 1,000 matches. Okay, so there's 2 options there for you, and hopefully that would be all right for you. Let's move on then to question number 16. Where we're being asked to draw on a grid the graph of x squared plus y squared equals 12.25. Oh, okay, so it's going to be a little bit tricky doing this on a screen, but we'll give it our best shot. Because really what we're saying here is that this is the equation of a circle. Okay, and actually 12.25 is the radius squared. Oops, let's just pop that down there, is the radius squared. Okay, so as a rough idea, it means then that the radius itself is going to be the square root of 12.25, which is 3.5. Okay, so the radius is going to be equal to the square root of 12.25, which is going to be equal to 3.5. And really it's just a matter of drawing a circle in the middle of the graph with a radius of 3.5. Okay, so the first one is around about here. Okay, remember this is 3 and this is 4, so halfway between the 2 is 3.5. Same again at the bottom there, same again there, and same again the other side is there. Now this is probably going to be the worst circle I've ever drawn. Okay, but I will do it my best because I don't want to move the grid too much for you. Okay, so I'll do it like that. Oh, that's a good start, isn't it? Okay. And then I'm going to do it, oh dear, around, like that. Okay, please don't judge me too badly on this type of thing. Okay, it's going to look more like an Easter egg than it is a circle, I think. But okay, that's an awful circle. Okay, I'm sure you will do a far, far better job than I will do. Okay, so then it says, hence find estimates of the solutions of the simultaneous equations, and it's got x squared plus y squared equals 12.25, and then 2x plus y equals 1. All right, So what we need to do, we're looking at this question at the bottom here, is we need to draw this line and look and see where the circle and the line cross, and that will give us the solutions. Okay, so it is estimates. Thankfully so, with my awful drawing here. Okay, but let's have a look at 2x plus y equals 1. Well, I need to rearrange that into the y equals mx plus c format. Okay, so I'm just going to do that first, and I'm going to say, well, actually I want to make y the subject. So if I rearrange that, I've got y equals minus 2x plus 1. So it's going to be a negative gradient, and then really all I need to do is to pop that into some sort of grid, and I've got x and y values. Now I tend to only do maybe 2 or 3 points just to kind of make sure I'm okay, and then because it's a straight line I could just draw it relatively easily on a graph. So I'm just going to use 0, I'm going to use 2, and I'm going to use minus 2. Okay, and if I pop 0 into here, I've got minus 2 times 0 is 0, plus 1 is 1. Minus 2 times 2 is minus 4, plus 1 is minus 3. Minus 2 times minus 2 is 4, plus 1 is 5. So actually I've got my coordinates now that I can draw my line. Okay, so the first coordinate is going to be 0, 1, so that's here. Okay, second one is going to be 2 and minus 3, so that's going to be down here somewhere. Okay, and the last one is going to be minus 2 and 5. Now, you might draw, more points, and that's perfectly fine. If you want to do that, it's not a problem at all, because all we're trying to do really is just find out where this line crosses the circle, because where it crosses the circle is actually going to be the intersection points. Okay, the estimates for the solutions. Okay, now I did do some notes on this particular one, so I'm going to very swiftly move my awful circle off the grid and say that actually it crossed at 2 and minus 2.8, which is one of the coordinates. They're the ones I got, and also minus 1.2 and 3.2, which is the other coordinate that I got, okay, on the notes that I did a little bit earlier on. So hopefully that's okay for you. There is a bit of a range with these sorts of things, so don't be concerned too much if your graph is a little bit off and your points are not quite the same as mine. I'm sure actually yours are probably more accurate than mine. Okay, let's move on then to question number 17. Question number 17 is a histogram. Very popular actually with a lot of these type of exam boards. Certainly Edexcel seems to quite like doing histograms. Okay, and they follow the same sort of format. Again, if you're not sure, please do have a look at the playlist on the channel about histograms, because really all we're doing is we're saying, well, actually we're going to apply a particular formula, and the formula we're going to apply is frequency density equals frequency divided by class width. Okay, so with all of these we've got the class width. Okay, in this particular case we've got a frequency. So what we're saying is that if we divide the frequency of 4 divided by the class width of 5, it's actually going to give us 4 over 5, which is going to be, and if you go back to the diagram itself, is going to give us 0.8. Okay, which is the first column. We need to really apply the same principle for all of the rest of them, but in this particular case we've actually got the frequency density and the class width, so we're going to multiply those two together and that would give us the frequency. Okay, so what we've got is the in part 2 here we've got a class width of 10 and we've got a frequency density on the graph of 0.4, so that's going to be 4 again. Okay, similar sort of thing, we've got a frequency density of 0.6 multiplied by class width of 10, so that's going to give us 6. Okay, we've got a frequency density of 1 multiplied class width of 5, so that's going to give us 5. And then we've got 0.2 class width of 20. Okay, and that's going to give us 4. So actually what we're saying is overall there's actually 23 in this particular group of students taking time to finish a puzzle. Okay, that would give you 2 marks, and then it's really time to move on to part B. Okay, now part B, it says, I won't actually go to it because we need to go back to the graph itself, but it says find an estimate for the lower quartile of the times taken to finish the puzzle. Okay, well, the lower quartile is the amount of students that we've got, or a quarter of the amount of students that we've got. So what we do is we take the first student, okay, and the 23rd student. Okay, we know there's 23 altogether, so it's 23 plus 1, okay, and we want to quarter them, so we're going to divide by 4, so that's actually going to be 6 students altogether. Okay, so what we're looking at then is going to be an estimate for the time taken for those 6 students. Okay, so if I go back to the graph itself, it means then that I can say, well, I know there's 4 students in the first column. I also know there's 4 students in the second column, okay? But I'm going to divide it neatly into 2 each side, so that's my 6 students, okay? So the estimate for the time is going to be 10 minutes. Okay, so those 6 students in the lower quartile, an estimate would be 10 minutes. Okay, and that's the answer to that particular question. Okay, so we're about 20 odd minutes into the video. I think we will do one more question, because if we do one more question, it means then the final video probably will be about 20 minutes as well, 25 minutes. So this particular question deals with a cuboid, and it's question number 18. Okay, and this one we've got to really try to be a little bit careful about how we work things out, but basically we're going to be using SOHCAHTOA because they're asking us to work out the size of the angle between AH and the bottom plane. So if I just sort of try to kind of draw that, I've got A to H is going to come along here, okay? Now that's corner to corner, it's opposite corner to opposite corner. So actually we've got this situation like that, okay? So in order to do that, we're going to work out this angle. We've also got to at least first work out the values of these lines if we can. Okay, so let's have a look at that. Well, I've got this situation where I've got a triangle that looks like that. Okay, and I've got an opposite of 7.3. Okay, so this is the bit at the bottom. This is actually, we're looking at the bottom triangle here. Okay, so that is this one. So this is A and this is B, and we know this is 7.3 because it tells us here. Okay, we also know that the angle BCA, so this is BCA, is actually 48 degrees. Okay, so this one here is 48 degrees. Okay, and this is C. All right, so if we just look at that in isolation, what we're going to try to do is we're going to try to work out the value of the hypotenuse, which is this one here, the longest side of the triangle. Now the reason we're interested in this hypotenuse is because it's actually going to be this bit here, and remember what we're trying to do is work out this triangle. Okay, so let's work and concentrate on finding out this hypotenuse. So remembering our SOHCAHTOA, and I usually make a point of writing it down, okay, what I'm going to use is the sine rule, because I know the opposite is 7.3, I want the hypotenuse, and I've got the angle. So I can say that the sine of 48 degrees equals the opposite divided by the hypotenuse. Okay, right, so if I want to find out the hypotenuse, okay, with a little bit of algebra, I multiply both sides by hypotenuse and then I divide through by sine 48, but I don't know how you would do these things yourselves, but I would say that hypotenuse is equal to the opposite divided by the sine of 48 degrees, which is the opposite is going to be 7.3 and the sine of 48 degrees is whatever it is, okay? And that will give us then the hypotenuse value, which remember we do need for this ACH triangle. The hypotenuse value is going to be 9.823. Okay, so in other words, we're saying this bit here is 9.823, or if you like, this here is 9.823. Okay. So we're in a position now where actually we know the height of this big triangle because it tells us it's 8.1. So what I'm going to do is I'm just going to draw another triangle here at the side. So what have we found out? Well, we know the height of it is 8.1. We know it's a right angle triangle because it's a cuboid. We've also worked out now that the bottom here is 9.823, okay? And what we're being asked to do is to find this angle, so we'll call it x degrees, okay? So I just want to try and relate that back to the diagram. So now what we've got is that triangle is this one here, okay? So we've got this one here. It's a little bit difficult to see, but hopefully you'll be able to see it okay on the screen. Okay, so we've got the components that we need because we can say this is the opposite, this is the hypotenuse, and this is the adjacent. Okay, remember it's always opposite the angle, and the hypotenuse is always the longest side. So again, using my three ratios, sine, cosine and tan, okay, I'm actually going to choose tan. Now the reason I'm going to do that is because I know the opposite, I know the adjacent, and I've got to work out the tan of the angle. Okay, so we can say the tangent equals the opposite over the adjacent. Okay, so in this particular case that's going to be 8.1 divided by 9.823. Okay, so remember that when we feed that into a calculator it's going to give us the tangent. It's not what we're interested in. What we're interested in is the actual angle itself. So if you use if you're using a scientific calculator, if you use the shift tan key, you're going to get the inverse of the tan, okay, and it's going to look something like tan minus 1. Okay, so the inverse function is what you're looking at. So if you plug this into your calculator, what you should get is the total angle of 39.5 degrees, and that's the answer to this question. So it does take a little bit of thinking through, and you need to almost kind of visualize these things in your mind before you set about them. But really, most of these questions they're either based on SOHCAHTOA or Pythagoras. So if you have a look at the playlist on 3D Pythagoras or some of the SOHCAHTOA ones, then hopefully it'll give you a little bit more, a few more examples to have a go at. Okay, so that's 29 minutes into the video. We're going to stop there. I hope it's been useful to you. Please do add any comments below, and I look forward to seeing you inside the next video.